All right, guys, so we're on lesson 6.4. Everybody have it open? Yep. Okay, so what we're going to be doing today is we're going to learn how to solve trig equations using our trig identities. So everybody should have that reference sheet out and next to them at all times until further notice. Okay? You cannot forget it. It has to come with you every day. All right? Okay, so basically what we're going to be doing is we're going to be combining the two things that we've been doing for the past 2 weeks into one. All right, we already know how to solve trig equations. We know how to factor them. We know how to find the angles. We've done all this. We know how to substitute in the trig identities. We did this last time, so we're just going to put them together. All right, not that difficult. Okay, so some trig equations can only be solved algebraically using substitution of the trig identity. These are just a few of the ones that we've looked at. Okay, that first one, cosine squared theta plus sine squared theta equals 1. What is that called? You're supposed to memorize it. It's not on your reference sheet. Good, your Pythagorean identity, right? That one has to be memorized. What I'd like you to do right now is in your notebooks, I want you to write that Pythagorean identity, and I want you to write it in all 3 of its forms that we've talked about, okay? So we've written it in 3 different ways. They all mean the same thing. They just look different. So I want you to go ahead and write those 3 down. Okay, so somebody give me the first one. Good. Excellent. What's the other one? Good. Okay, so you need to be able to think of them in all 3 ways. Okay? Sine squared theta, if you see sine squared theta, you know you can substitute in 1 minus cosine squared theta if you need to. Okay, so you do have to know all the separate forms, and we are going to be using this quite a bit. Ready? Okay, so let's take a look at the first one. Sine 2a minus cosine a equals 0, and we're on the interval from 0 to 360. So sine 2a minus cosine a equals 0. What was it, minus cosine a? All right, so I want to solve this, okay? What's the first thing that you notice? What's popping out at you? Okay. Yeah, sine of 2a. What do we know about sine of 2a? Where have we seen that before? Good, it's on our reference sheet, right? Okay, it's on our reference sheet. It's one of our double angle identities. So if you look at your reference sheet, notice functions of the double angle, we have sine of 2a. Okay, so what do you think I'm going to do with sine of 2a in that equation? I'm going to substitute in what? Good. So I'm going to replace this with its identity, 2 sine a cosine a. And then I'm going to keep what I had. Okay, so it's just substitution. All right, what can I do from here? Think about algebra. Think algebraically. What can you do to this equation? Factor what? What's my GCF? Good, cosine of a is my GCF, so I'm going to factor that out. What goes in my parentheses? Good, 2 sine a minus 1. Excellent. Now what? Good, what's that called? Zero product rule, good. Excellent. Okay. When's cosine equal to 0? 90 and 270. Great. Okay, 90 and 270. You're thinking about that unit circle, right? 90 and 270 is where cosine is 0. Okay, and this is sine A equals a half. What's sine is at 30. 30 and what? Remember, we're talking about a positive 1/2. So you have to think about both quadrants that its sign is positive in. 150, great. Right, and we got this because it's 180 minus theta. Gives a side angle. Okay, so my solutions, we're going to write them in what order? Ascending. 30, 90, 150, 270. And since there's multiple, we put them in curly brackets or braces. Okay. What do you think? So you guys know how to solve the equation. You guys are good at that. We've spent a ton of time doing that. Your only issue is when or what identity do I plug in? Okay. So sometimes you're going to get them wrong. You're going to have to try a different identity. That's okay. You just have to keep trying. Are you ready? Okay. All right, so let's look at the next one. Cosine 2a plus 5 cosine a plus 3 equals 0. We're on the interval from 0 to 360. Okay, what's jumping out at you? Cosine 2a, right, I've seen that before, right? Cosine of 2a, 3 options. Let's go back and look at this problem again. I've got 3 options there. I know that I'm dealing with a cosine. Now, all of my options contain a squared, right? So chances are I'm probably going to try and factor this. If I want to try and factor it, what do I have to keep? What do I want to make sure we have? Yeah, so if I'm looking at this reference sheet, if I'm dealing with these 3 here, do I want anything with a sign in it? No, okay? Because then I'm not going to be able to factor the way I want to, since we're not talking about GCFs, we're talking factoring a trinomial. So this is the one I'm going to have to use, 2 cosine squared a minus 1. Okay, we're keeping the trig functions all the same. We're using all cosine, all sine if we're going to go that factoring route. The last one we pulled out of GCF was a little different. Okay, so 2 cosine a minus 1 is going to be our substitution. All right, so this is going to become 2 cosine squared a minus 1. Is that right? Okay. Plus 5 cosine a plus 3 equals 0. Alyssa wants to say something. What? You were looking at it like you were going to say something. What do you think we would do next? Yeah, absolutely. Combine like terms. So 2 cosine squared a plus 5 cosine a plus 2 equals 0. Okay, just combining like terms. Now what? Yeah, factor it. So how do I have to start? Is there a GCF? No. So it's straight factoring here. Good. 2 cosine a and cosine a. Great. Yep, both going to be positive. Well, my only options are what? 1 and 2, right? It's got to multiply to be 2 on the end. So my only options are 1 and 2. It's just going to depend on where I'm going to put them. I want it to add to be 5 when I FOIL it back out. Good. Yeah, if I put this here, the reason we're thinking that is because when I go to multiply this, what's it going to give me? 4. So I want this to be 1 to give me 5. Okay? So you have to think about it like that. And how can I make sure I'm right? FOIL it out. Yep. So I get 2 cosine squared a plus 4 cosine A plus 1 cosine A plus 2. Does that give me my 5? Awesome. Okay, so I'm not going to leave that. I'm just checking myself. Okay. Now what? Good, zero product rule. 2 cosine A plus 1 equals 0. Cosine A plus 2 equals 0. Cosine A equals negative 1/2. Good. And cosine A equals negative 2. What can I do automatically? Yeah, I'm going to reject this. Why? It's less than negative 1, right? It's outside my range for cosine. Okay, so I'm concerned about where cosine is equal to what? 1/2, right? So when I take the inverse, which is how I get the angle, I have to take it of what? Positive 1/2, because that's going to give me my what? My reference angle. When is cosine equal to 1/2? 60. That's my reference angle, right? Do I want the reference angle? No, because I'm concerned where cosine is equal to a negative. Where's cosine negative? Second and third. Okay. How do I get the angle in the second quadrant? Yep, 180 minus. How do I get the angle in the third? Which is going to give me 240. So my solutions are 120 and 240. Is it all coming back to you now? Yeah. All right, so a lot of times we're going to wind up using that Pythagorean identity. So that's your sine squared theta plus cosine squared theta equals 1. It's not always going to be in that form. That's why we have to know the other two, because we're often going to have to use that variation. So I've got the equation cosine squared x plus 4 sine x plus 4 equals 0. And I want to solve it on the interval from 0 to 360 degrees. Okay? Now what's kind of troubling you about this quadratic? Yeah, it's got cosine and sine. Do I want cosine and sine? No, not if I'm going to factor it, right? I don't have a GCF, so I want to be able to factor it, and I can't do that if they're different. So we have to think about that Pythagorean identity. What in that equation can be replaced with an identity? What in that equation can be replaced with an identity? Yeah, cosine squared x. Okay, that can be replaced. Okay, when we talked about our Pythagorean identity, we said one of them, cosine squared x, is the same thing as 1 minus sine squared x, right? That was one of our Pythagorean identities. So if I were to substitute this in for this, would I now be in terms of sine, which is what I want, right? Okay, so there's the substitution we're going to make. Okay, so again, we're saying this is being replaced with what? Yeah, 1 minus sine squared x plus 4 sine x plus 4 equals 0. Okay, so we're making that substitution so that we can get it into all in terms of sine so that we can factor it. All right, so what's my next step? Sure, combine my like terms. I've got a plus 1 plus 4, which is going to become 5. Yeah, I don't like that negative sine squared x. It's annoying me, right? So how do I get rid of it? Yeah, multiply everything by negative 1. So that's essentially just going to change all my signs for me. Great. Nice job. So now it's easier to look at, right? I've seen this before. This is actually really easy to factor. Okay, if you need to think about it in terms of x squared minus 4x minus 5 equals 0, then do that. But this should be pretty simple. All right, you know how to factor that. So how's this factor, guys? Yeah, sine x minus 5, sine x plus 1. It's going to multiply to be a negative 5, add to be a negative 4. Okay, good. Keep going. Good, I can cross this one out. Why? That's larger than 1. 1 sine equals negative 1. Negative 1. 270. That's it. 270 degrees is your answer. What do you think? It's not too bad, right? Takes getting used to. We're going to do lots of practice. Are you ready? Yeah? Okay. So let's see how far you guys can get with this one on your own. Okay, and we'll come back together and go over it. Okay, somebody tell me how they started. There's more than one way to do it, so give me something. Okay, what'd you substitute? Okay, anybody do anything different? What'd you do different? What did you use? Okay. Sure, we can distribute. So you were over here, right? So 6 cosine squared should be theta minus 3 equals 2. What did you do next? You distributed as well? Okay. There's more than one way to do it. This can be done multiple ways. I probably, if I were doing it, I probably would have started by dividing by 3. Yeah, sure. So it doesn't matter which way you choose to do it. We're all going to get to the same answer in the end. Okay? Okay, so what's my next step here? You move the 3 to the right. And what did you do? Did you move the 3 to the right as well? She moved the 3 to the right as well. Okay. Yep. How about over here? Divide. Okay. Now what? Yeah. When I take the square root, I have to remember to do what? Plus and minus. Good. So sine theta equals plus and minus the square root of 1/6. Cosine theta equals plus and minus the square root of 5/6. Okay. How do I get the angle? I take the inverse. Good. To get the angle, I take the inverse. So I'm going to do sine inverse of the square root of 1/6, or cosine inverse of square root of 5/6. Please do it and tell me what you get. To the nearest tenth. Good. For both, yeah. Okay. But what do I have to keep in mind here? That's okay. Think about where I want my solutions to be. took the square root and I got plus and minus. Where are my solutions going to be? Everywhere, right? I'm going to have 1 in every single quadrant. So I've got the 1 in quadrant 1 already. How do I get the 1 in quadrant 2? Good. How do I get the 1 in quadrant 3? And how do I get the 1 in quadrant 4? Find them, please. Okay, what'd you get in quadrant 2? 155.9. Quadrant 3? Quadrant 4? Good. Questions? Concerns? We're going to do lots of practice. We get in the hang of it? You know what you're looking for now, right? You're looking for those identities to figure out what you can plug in. Okay. So we're going to show that this one has no solutions. Okay, so we're going to start by looking at what we have and what we want to possibly get rid of. Okay, so what up there is concerning you? What up there can be replaced? Say it again. Yeah, cosine of 2 alpha, right? That can be replaced. That's one of our identities. You're looking for identities. Okay, now, how many options do we have for cosine of 2 alpha? I have 3. Which one am I going to want to use? Yeah, the one with sine, because I want everything up there to be in terms of sine. Okay, so 1 minus sine squared alpha. A is just a variable. Okay, so I'm going to, these are alphas. That variable is alpha. Okay, so I'm going to replace cosine of 2 alpha with 1 minus sine squared alpha. And the reason I did that is because I want them all to be in terms of sine. Okay. Okay. Good. Combine like terms. So I get negative sine squared alpha plus 3 sine squared alpha. It's going to give me 2 sine squared alpha minus 6 sine alpha. And then 1 plus 7 is 8. Okay. What can I do? How can I factor to start? You always look for what to start. A GCF. Do I have one? What divides into 2 sine squared alpha, 6 sine alpha, and 8? 2. Pull out a 2. Yep. Oh, thank you for catching me. My bad. I apologize. 1 minus 2, which is going to make this sine squared alpha, right? Correct? Yeah? Thank you. Sorry about that. Terrible teacher. Fired immediately. What? Right, no GCF now. Now we can go straight to what? Factoring. So sine alpha, sine alpha. So what multiplies to be a positive 8 and adds to be a negative 6? Yeah, minus 4 minus 2. Okay. Now what? Good? So I get sine alpha equals 4, sine alpha equals 2. Yeah, I have to reject both of these. They are outside my range, right? So there is no solution here. So that's algebraically how you show that there are no solutions. Okay? So your homework tonight is pages 12 and 13. Please make sure you get that done. We're going to finish this lesson tomorrow. and we'll go from there. All right, guys.